In this video, we're on Skill 2 under Chapter 11. We're going to do number 8, 1, 4, and then there's another 8, but they're not identical. So we're going to take care of these, and then remember, if you have problems with any of the other ones, the solutions are worked out on Moodle. So let's go ahead and start off with the first 8. The first 8 is a heating curve, right here. Okay, so on this heating curve, it tells us that this is for water. Right, so that's essential. Which of the following statements is not true? So first, let's take a look at this heating curve. What do you know about water from negative 25 degrees to 0 degrees Celsius? What phase is it? So hopefully you said solid, right? So from here to here, we have a solid. So what happens at 0 degrees Celsius? So what's happening from here to here? Because temperature stays constant. So this would be a phase change. Specifically, if we're moving in this direction, heat's being added, that solid would melt. So when ice melts, the temperature is all the way melted, the temperature starts to rise again. Well, this is a liquid. Right? So gas is not shown in this heating curve. There we go. So let's go ahead and take a look at the statements and figure out which ones are not true. So letter A, at 0.5, the material is ice. There's no liquid present. Well, that was easy. Since we labeled it beforehand, that's not true. That's our answer. Let's just go through and make sure we agree with the others so you get used to reading a heating curve, because this is the only question with a heating curve on it. Adding heat at 0.2 makes the molecules move faster. So yes, we're adding heat here. The molecules are moving faster. They're trying to break apart. As soon as we get to that 0 degrees Celsius, they can start to break apart. Adding heat at 0.5 makes the molecules move faster. True, because then it starts to go up again. At points 1, 2, and 3, the material is ice. We already said that. Adding heat at 0.4 breaks some intermolecular bonds. That's true. We can't say all intermolecular bonds because some are still being broken as we make our way towards 0.5. Right? Average kinetic energy does not change when heat is added. This is also true because average kinetic energy is related to temperature, and what's happening to temperature at 0.4? It's staying constant. Easy enough. Sorry. Okay, let's go on to number 1 right below it. So from here on out, the rest of these questions deal with phase diagrams that look like this. So the picture illustrates a phase diagram. Which points describe the curve where the solid and gas phases coexist? So I'm going to go in and shade wherever I have solid. I'm going to shade wherever I have gas, so that it's a little easier to see. So right here, this is all my solid. Right here, under here, this is all my gas. So which points describe the curve where solid and gases coexist? So you can now see right here, the shaded regions touch on both sides. So that's letters I through J. That's a J. So A. Let's go down to the next one. Sorry. The arrows in the phase diagram represent the starting and ending points for some process. Which arrow labeled I, J, K, N, or M, so all these red arrows, describes a phase change that occurs through a constant pressure heating. So let's focus on the word heating. Temperature is going up as we move to the right? So we know that this isn't being heated, this isn't being heated, this isn't being heated, and neither is this because it's going the opposite way. So our answer must be in. But let's go ahead and look at constant pressure. So pressure is on the y-axis. So you can see here, pressure is not changing, right? And so these would not work because pressure is changing in all of them. Finally, let's do the last number 8. Here we go. Which points in the figure of the phase diagram are correctly identified in this table? Okay, at this temperature and pressure, gas is the most stable phase. So let's go find the gas. So gases are all here, right? So we have a gas at number 1. We could have a gas at 5 and 4. So which one is the most stable? Hopefully you said number 1, because what's happening at 5 and 4? Gas is being shared with the liquid. So there's an equilibrium between gas and liquid. It's not the most stable. It's between 2 phases. That's true here and here. So 1 would be the most stable. Okay, so now we're down between A, B, and D. All right, so molecules in a fixed rigid position, that means solid, right, coexist with molecules that can flow. Flow means liquid. So let's find a point where we have an equilibrium between solid and liquid. Well, here's our solid, here's our liquid. So where are molecules sharing that? At 3 and 2. So 1's out. All right. So now we've got A gone, C and E gone. All right, normal boiling point. So remember, normal has to occur at 1 atm. Boiling is from liquid to a gas. So liquid to gas at 1 atm is occurring here at 0.5. It's going liquid to gas at 1 atm. So these are all gone. So the only answer is B.